Hello everyone, welcome back to our remote sensing series. In the previous lecture, we learned about electromagnetic radiation and radiant energy. Now, question come to our mind: how do scientists measure this energy? Okay, so do they only say the is giving energy? No. Scientists measure radiation in different ways depending on time, area, direction. That is exactly what we are going to learn today's lecture. Okay. So mm, let's start. Okay, and don't worry if these all terms look difficult. By the end of this lecture, they will become very simple. Okay, so first one is radiant flux or power. It is defined as the radiant energy per unit time and mathematically expressed as phi equal to d phi upon dt. Radiant flux or power is expressed in watt. So first of all, let's understand in easiest term. So imagine you switch on a light bulb. The bulb continuously giving out light energy every second. The total amount of energy emitted every second is called radiant flux, also known as radiant power. So the total amount of energy, what is called radiant flux. In simple words, radiant flux means total radiant energy produced in 1 second. What is radiant flux? Total radiant energy produced in 1 second. Okay, so in per unit time. Okay, so formula क्या है? Phi equal to dq upon dt. Here phi means radiant energy, t means time. So what is radiant flux? Energy divide equal to energy divided by time. Its SI unit watt. So for example, if what bulb you switch on, so if bulb emit 100 joules of energy in 1 second, so its radiant flux is 100 watt. So remember one point: radiant flux tells us only the total energy emitted. What tells us? Total energy emitted. Okay, it does not tell us where that energy is going. Clear? Next term, iridescence or flux density. What is? First of all, we read this. So it describes the amount of incident radiant flux per unit surface area. This is area and this is radiation. Okay, so this is radiant flux shown by arrows. E equal to d phi upon dA watt per meter square. Iridescence at a specific wavelength is known as spectral iridescence and it is expressed as E lambda. What is figure? Figure A, iridescence, and figure B, E. Okay, figure B, yeah. Radiant emittance or radiant existence shown by figure B. What is emittance and what is excitance? And what is M? M is flux per unit area away from the surface. Okay, so let's understand this. So now imagine sunlight is falling on the earth's surface. The earth receives this energy. The amount of radiant energy received by surface per unit area is called iridescence. Here is per unit time and in iridescence per unit surface area. This is the difference. So in simple words, iridescence tells us how much incoming energy falls on a surface. Irradiance. tells us how much energy falls on a surface. Okay, and formula equal to d phi upon dA. Why? What is the area? So SI unit watt per square meter, meter square. So if you understand with an example, so suppose 1 square meter of land receives 100 watt of solar energy, then the iridescence is 100 watt per square meter. Okay, so if you want to, I think this is simple to recall. Okay, so okay, next there is term radiant emittance or radiant existence. What is shown by this figure? Energy incoming through the unit area is called iridescence. Okay, next radiant emittance or radiant existence. It describes the radiant flux per unit area away from a surface. This term describes the power per unit area radiated by a source or reflected from a surface. It is called spectral radiant emittance or radiant existence. When considered at a specific wavelength, it is expressed as m lambda. Okay. So now the Earth's surface has absorbed sunlight. After becoming warm, the Earth starts giving energy back to the atmosphere. The amount of radiant energy leaving a surface per unit area is called a radiant existence, also known as radiant emittance. So, what is the difference between radiant emittance and iridescence? Iridescence in iridescence Earth absorbed energy. Okay, and in emittance Earth emit energy per unit area. That's why there is no difference in formula. So the amount of radiant energy leaving a surface per unit area is called radiant existence, also known as radiant emittance. Its formula is also m equal to d phi upon dA, unit again watt per square meter. So you may notice that formula is the same as iridescence. Then what is the difference? The difference is very simple. Iridescence means energy coming into the surface and radiant existence means energy leaving the surface. So an easy take is M means moving out. Okay. To remember, always remember M means moving out. Okay. Then what is the difference between iridescence and existence? If you got confused, so I again clarify that. So remember this simple comparison. When sunlight falls on the earth, that is iridescence, and when earth reflect or emit energy, that is radiant existence. Okay, so incoming and outgoing energy. In first diagram, so we will discuss that. We discussed that this is iridescence, and in second represent diagram, arrows are moving away from the surface. Yeah, moving away from the surface. This represents radiant existence, which means outgoing radiation. This figure simply shows the direction of energy. Okay. Next, element of solid angle. The element of solid angle is defined as conic angle encompassing the area element dA on the surface of a sphere of radius r. It is expressed in SI unit of steradian. Okay. No, sorry. Yeah. Okay. So now let's learn about solid angle. So you already know what a normal angle. For example, 90-degree angle, 45-degree angle, 35-degree angle. What is this? So these are two-dimensional angle. When we write angle, so what we do? For example, 90-degree angle, so we write in two direction or two dimension. So normal angle is two dimensional angle, but radiation travel in three dimension. Okay, so instead of using normal angle, scientists use a solid angle. Imagine light coming from a torch. For example, if this is a torch and light coming from this, so how this look? It is spread in the shape of cone. The opening of that cone is called solid angle. So what is the opening of that cone? This. So what angle make in this particular area is called solid angle. So imagine the light coming from a torch is spread in the shape of cone. The opening of the cone is known as solid angle. Its symbol is omega and SI unit is steradian. Remember this. Okay. So whenever radiation is measured in a particular direction, solid angle used. Okay. I think solid angle is now clear. So next is radiant intensity. It is described as the flux per unit solid angle from a point source into a particular direction and is mathematically defined as I equal to d phi upon d omega, whereas d omega equal to dA upon r square, dA upon area, and it is called spectral radiant intensity when considered at a specific wavelength and expressed as I lambda. Okay. So now suppose a light source emit energy in different direction. Sometime we want to know how much energy is emitted in only one particular direction. This is called radiant intensity. Described as flux per unit solid angle. What is solid angle? Omega. From a point source into particular direction. So how much energy is emitted in only one particular direction, not area and not unit surface area, only direction. So it is called radiant intensity. Its formula d phi upon d omega, and SI unit watt per steradian. Unit of omega. So easiest intensity measure means direction. Okay. So for example, a laser emits light mainly in one direction. So it has high radiant intensity in that direction. Next, radiance. Radiance L is the flux per unit projected area at the specified location in the plane of interest per unit solid angle in the direction specified relative to the reference plane. This is the formula. So first we understand about this definition, then move forward. So what most important, this is most important quantity in remote sensing, radiance. Almost every satellite sensor measure radiance, so please pay special attention on this. So radiance tell us how much energy leave a particular area of Earth's surface in a particular direction. What we read in radiant emittance and radiance. What is the difference? In radiant emittance, we use only unit area, not direction. But in radiance, we use in unit area a particular direction. So, how much energy leaves a particular area of the Earth's surface in a particular direction is tailed as radiance. So notice that radiance considered three things together. First, area. Second, direction. Third, viewing angle. So that's why radiance is useful for satellites. And what is the SI unit? Watt per square meter per steradian. Watt is watt and per square meter or meter square and steradian. Okay, this is the unit. So imagine two agricultural field but receive the same sunlight, but one field reflects sunlight toward the satellite while the other reflect in different direction. So satellite receives only the energy coming towards it, that measure energy is called radiance. So always remember this point. Example in exam, satellite measure radiance, not irradiation. Okay. So what satellite means? Radiance, not irradiance. Yes, we have to write satellites measure radiance, not irradiance. So, uh, now a simple question. Why does the earth emit radiation? So the answer is every object whose temperature is above 0 Kelvin emit electromagnetic radiation. The sun emits a very large amount of radiation because it is extremely hot. The earth also emits radiation but mainly in thermal infrared region. So even the human body emits radiation. Okay. So hotter the object, more radiation it emits. What is right here? Electromagnetic energy is continuously emitted by all natural bodies having temperature T equal to 0 Kelvin. What is T equal to 0 Kelvin? When T equal to 0 Kelvin, absolute zero temperature. So the temperature and the composition of a body decide the spectral composition of the radiation emitted. The spectral emission of a body depends on the electromagnetic configuration of the atomic cell, and this configuration changes with temperature and is different for different material. So in simply that what is we discussed, the hotter the object and more the radiance is coming, that explained in this paragraph. Next term is black body. So, an ideal body that is completely absorb all the radiation incident on its surface is known as black body. The spectral emission curve of a black body is continuous while the emission curve of a natural bodies are discontinuous. That is made up of discrete spectral bands. Finally, let's understand in simple way. So a black body is an ideal object. It absorbs all the radiation falling on it. It does not reflect any radiation. It also emits the maximum possible radiation according to its temperature. So although perfect black body does not exist in nature, the sun behaves approximately like one. So scientists use black body concept as a standard to compare radiation emitted by a real object. Okay. So I hope this page is clear now. Let's quickly revise what we read in today's lecture. So the sun emitted total energy every second, that is called radiant flux. When this energy falls on Earth's surface is called irradiance, and when absorbing energy the Earth emit and reflect energy, this is called radiant existence. And if we measure energy in a particular direction, that is called radiant intensity. And when we measure outgoing energy from a specific area and in a specific direction, it is called radiance. Remember, satellite measure radiance, not irradiance. Finally, a black body is an ideal object that absorbs all incoming radiation and emits the maximum possible radiation. Okay, so in this next lecture, we will continue with the next topic of this book, gradually build to understand from beginner to advanced level. Okay, and if you find this lecture helpful, so you know what to do. And thank you so much, and very best for your examination.